Hey, my name is Joe from Vinci. In this video, I'm going to teach you how to add collision to the player's hands in virtual reality. It sounds easy enough, right? But we're going to do something a little bit different this video. We're also going to apply the same concepts we used to make the player's hands collide in VR, and then kind of abstract that and make it apply to any or every object you are going to be able to grab in VR as well. So by the time you're done with this video, you'll have constructed a working physical grab system that'll let you bring your base level interactions in VR to the next level. This tutorial series is going to be meant for intermediate level Unreal Engine developers. If you're a little bit closer to the beginner or a first time Unreal Engine user, you might get lost with some of the concepts we're going to go over pretty quickly here. So I recommend doing a beginner tutorial if this is your first time using Unreal Engine before stepping into this one. So with that out of the way, let's get started and head into the editor. Alrighty. So we're going to start with the VR template that you can create from the starter examples from Unreal Engine. The reason we're doing this is simply so that we don't have to do a whole bunch of extra work setting up like a basic pawn, like basic grabbable interactables and stuff like that. We're just going to want to work with what Unreal gives us so that we have a jump start to do the things we want to do. So what is our first step going to be? First things first, we want to make sure that the physical hands are actually going to be interacting with the world themselves. So we're going to want to set up hand collision. This is something you probably have seen before, and it's not too difficult to get going. So what you want to do first is open up the VR pawn in the blueprints for the VR template. Then we're going to look at this details section here, and we're going to try to enable collision and set simulate physics on for everything. So as you can see, we can't actually set up simulate physics yet. So why is that? The reason why that is because we're actually missing a physics asset for our skeletal mesh. It isn't like a static mesh where you can just use simple collision. Skeletal mesh, you actually do need to set up some type of interactable physical network or whatever. So how do we do that? It's pretty simple. We go to right click on our hand, then we go to create, and there's going to be at the top of the list physics asset. You can tap create. Just go with the default values and create that asset. It's going to open up it in an automatic window. So over here you can see we have it set up. What I'm going to like to do is just scale it down a bit, rotate it out a little bit so that we're actually approximating the hand a little bit better. Hit save. We can go back to the same content browser. Instead of going all the way back to the pawn, we can just see right here that there is, in fact, another hand here that we need to create an asset for. Do the same thing as you did before. You can see here the hand exists in space, and we're going to rotate so that, once again, it roughly matches the vector that we want. Close out both of these. We're done with this for now. Then we can go back to our hand, go to this physical asset override. Then we're going to just apply the one that we created to it. Now you notice that simulate physics is actually available to hit true now. So we're going to go here, do the same thing for the right hand. Now, another thing that we want to do is set up a physics constraint. So what exactly is a physics constraint? Well, it's important for us to understand what this is because it's going to be the primary way that we're going to be interacting with grabbed objects in the world from now on. So what a physics constraint does is it basically takes two bodies and then it will connect them using Unreal's physics system, and it will perform a bunch of actions depending on the parameters you set in the component. So a very simple way to do that is by just entering the component names that already exist in the actor and then linking them using this little parameter here. So right now we do have some components to work with as a hand, but we don't have something that's going to be what I'm going to call a driver. So in order for the physics constraint to start working its magic, we're going to need to add an object that's going to represent where our motion controller is in Unreal space. And for that, we're just going to use a very small cube that's center aligned. Then we're just going to want to make sure this is hidden because we don't want to see this. This is just going to be an invisible driver for physics. we can name this variable to physics driver left. Then we just want to put this on overlap all, just for fun. That's about all we have to worry about for this, to be honest. We go back to our physics constraint. We want component 1, which is going to be what drives our physics. And spoilers, this is going to be the physics driver left. We're going to type in on the component name 2, which is going to be what's driven by our driver, which is going to be equivalent to the hand left. There's going to be a couple of values we're going to want to set in this as well. Primarily, we're going to want to change these linear limits to be having a little bit more freedom. So this is going to make it so that the hand can move away from the actual motion controller to a certain extent. So here it's going to be like, okay, we have 100 units that it's going to move away from, and it's going to be just fine. Another thing we want to do is disable projection. Projection is basically something that's going to teleport our driven little components if they get out of a certain tolerance, but we don't really want to worry about that for now. What we want to do is just for fun, disable collision between the driver and the hand, as it's not really going to be too much important for us. So for angular limits, pretty simple. We want it to be locked directly to our motion controller because we don't really have a reason for our hand to have much limited range of motion here. We want it to just be one-to-one. How we're rotating the controller is going to be how our hand rotates. So we are going to have a linear motor. It's just going to have a normal position target. And we're going to add a strength of 2000. This basically is going to make sure that our hand is always going to be moving towards the driver. Same thing for the velocity target. For the angular drive mode, we're going to want twist and string. This is just how twist and swing works. It's the best option we have right now for what we're trying to do to make the hands follow our driver. We're also going to set up the target velocity here. And then it's going to be 50 strength, 50 dampening for our angular motor. And that should be it for now. However, there's a couple of things we do want to do with this. For instance, first things first, you're going to realize that we only set up one of the hands for this system. The other thing is that we actually need these hands to act as a physics actor now, as opposed to, just no collision. So we'll start that for the left one. Another thing that we want to do is, since these objects are going to be no longer attached to the motion controller, we're going to want to deparent the hands from the motion controller and just leave them parented to the origin of the actor. So I'm going to go ahead and do the same thing for the right hand. Set it to be a physics actor. Make sure that simulate physics is on, which it is. We have the physics override set, if I recall correctly. So that should be good. So the next step is just to copy our physics driver, put it into the grip for the right hand as well. Change this to physics driver right. Copy the physics constraint. We can change this to left. Add this as well to the right grip. We're just going to want to change the components that we have here so that they properly align. You can see that visually it should change as well. So once you change the names of the components inside the physics constraint, you'll see that these little graphics that represent the actual constraint will change on top of everything else. All right, so this is actually the end of the first step, which is to get our VR hands to work and actually interact with the world. So I think it's about time we can pop on the VR headset and see what our progress is like. Right off the bat, there is one little bug that I encountered. If you don't happen to drag the spawn point up, your hands will collide with the world on spawn, and you won't actually get a pawn to possess when you play an editor. So as a start, you're going to want to just drag up the spawn point to make sure that it's something that lets you spawn in. But otherwise, it seems to be working pretty well. Our hands will collide with the environment. They even kind of trigger and hit each other in physical space, which is kind of funny, but that's awesome. But what we can see here is that they will collide with the world, but the objects you pick up will not be colliding with the world. So the next step is to make that work. So now that we know that our hands are working in VR, the next step is going to be to alter our grab component so that we can actually set it up so that the objects we're grabbing do the same thing as our hands. It's actually not going to be too difficult. The first thing that we're going to do is open up the grab component provided by the VR template. Then we're going to make some changes to this little component class so that it will work with physics constraint as opposed to just raw attachment. So as a start, we're going to want, just for ease of access, we're going to need a physics constraint reference as a variable. We're going to make sure this is referring to a physics constraint component. And another thing we're going to want to do at the start is, on top of having the motion controller, we're also going to want to pass in a primitive component that's going to act as the handle for what is driving our grab itself. Got that in here. So as you can see, not too much going on with this grab. However, there is something we want to change here. For the free grab, we're going to want to make sure that physics is being simulated, as now we're going to be using a physics constraint. Naturally, we're going to want simulate physics to be on. Okay, so there goes that. Then the next step is going to be a pretty simple change. We're going to be getting this physics handle, and we're going to be passing this into our little macro to attach the parent to the motion controller. We're also going to be changing this class to say attach parent to physics constraint. And how are we going to do that? Change this to handle. And we're going to open this up, and then we'll be showing you exactly how we do this. So as a start, we can just make sure that this physics constraint is valid. If it's not valid, then we're going to be going through the same path where our grab is not going to be working properly here. I'm going to drag this down, get rid of this as we don't need it. We do need the attached parent still. What we can be doing with the attached parent, we'll show you in a second. So first things first, we want to break the constraint. This is so that if we're grabbing an object that's already grabbed, or if there's something going on with that object, we want to make sure we clear that so that there is just no problem with the grab that's about to happen. Let me get the attached parent. Then we're going to be using a pretty simple function here called set constrained components. Kind of similar to what we did before with the hands, where, okay, we want to set two component names. Now we're going to be just directly setting the components using this function here. Oh, that's a weird little thing. So how are we going to be doing that? Well, now what we want is this handle right here is going to be used as our physics driver. Ooh, handle. And this is going to want to be changed to the primitive component itself, which is fine. After this, we want to just make sure our attached parent is the driver. We actually want to do another check here and cast this to a primitive component. That way we make sure that we're actually doing a physical grab on our attached parent. Otherwise, we want to just go to a failed grab. If this is successful, then we can go ahead and constrain our components. Now this should be setting it up so that our try grab will once again be working properly as long as our grabbable object has the proper pieces in place, which we will set up in a second. Now we have handled the free grab, which is a little bit simpler. When it comes to the snap grab, we're going to need to do a little bit more work here. So we are going to want to turn off simulate physics for the snap grab, simply because we're not going to be attaching until later. First, we're going to want to set up some of our rotations here. So one thing we can do is move these to be at the end now. Drag this up here. Also going to want to set physics to be on again, as we do need physics to be on in order for our constraint to properly attach like we just went over. So that leaves us with a little bit of work to do here. So in Unreal's example template, we have it so that we set the relative rotation as we're going to be attached to the motion controller directly. But since we're using a physics constraint, that doesn't quite work for us anymore. The good news is that this whole world location thing does work pretty well. We're going to turn off teleport just so that the physics state doesn't get messed with. Then we're going to want to set world rotation as opposed to setting relative rotation for our rotation. So how exactly is this going to work? So there's a couple of nodes here that are going to come in handy. But first I just want to clean up our workspace here so that we have some stuff to do. So primarily what we're going to want to do is we're going to want to get our physics handle. And then we're going to be getting the world transform of our physics handle so that we can kind of transform the rotation of our grab component itself. So we're going to go ahead and get relative rotation of our grab component. We'll show why this is important once we get to the little pistol in a couple of minutes here. Then there's going to be two things we want to do here as well. One thing we're going to want to do is transform rotation. What this is going to be doing is it's going to take our relative rotation and then make it so that it is now relative to the world transform of the physics handle as opposed to kind of just the attached parent of the grabbed object, if that makes sense. We're also going to want to invert the rotator, which we do right here, which is great. Then there's going to be one last thing that we want to do here, and that's going to be selecting this rotation depending on what hand we have equipped right here. So what exactly are we going to want to do in order to set this up? Well, you would think we could just use this handy get held by hand function, but the problem with this is that we would need to be setting the motion controller reference before we actually confirm a grab with our try grab function. So what we are going to be doing is we're going to be taking out the motion controller ref, and we're going to be referencing the local variable of the motion controller inside of our function for trying to grab, which is a little confusing, but for now and the purposes of this little demo here, it makes a little bit of sense. You're going to see here a whole bunch of extra values as well if we do that. So what I'm probably going to do here is just do a equals to, and then this will set it up so that we don't have to worry about all those extra values for now. Since realistically, all we're worrying about is left hand or right hand. We don't need to worry about like a million different motion sources in this tutorial, at least. So that should set ourselves up for this whole try grab function here. You can drag out the comment just so it makes more sense. Drag this down a bit. And we call our on grab and all these other functions just fine. And as it goes for try release, it's actually pretty simple, luckily. We can open up the try release function. Then if we go down to where it's going to detach from component, instead of detaching from component, we're just going to refer to our physics constraint reference. The physics constraint reference, we're going to check for validity again, just because this is something that may end up causing a lot of error codes if you do not. If it's valid, we're going to be breaking the constraint, kind of like what we did in the beginning of our grab to verify that we're not going to be doing double constraints here. If it's not valid, we're just going to pass through and then make it not held either because we still want to handle the release event. And there we go. This should be pretty decent right now for our little physics IK system for grabbing an object. The next step is going to be creating a parent class for all of our grabbable objects so that we always can make sure we have a physics constraint to work with on something that's grabbed. So in order to do that, it's actually going to be pretty simple as well. What we could do is just create a new actor here. Go to Blueprint, create a Blueprint class, just make it an actor. BP, we can call this master grabbable. Go ahead and save that. Right now we have just an empty little scene. But we do have a reference that we can start with for a grabbable that's going to be pretty simple. That's going to be the grabbable small cube that gets provided by Unreal's template. This is a very simple class. You can see there's a static mesh and a grab component. So I'm going to go ahead and do is just copy and paste both of these little components here and just drag them into our master class here. Gonna go ahead and compile this. Then what do you know? Already we have a grab component. We have a static mesh that has physics actor, and it's going to follow some of the same rules that we wanted to go by before. The problem is that this is kind of scaled strangely. So we kind of want to just make this scaled up a little bit so that we always have a 1x1. And there's a couple of things that we're going to want to add to this. Primarily, we're going to want a physics constraint. So what I like to do is, for the purpose of this tutorial and speed, we're just going to copy and paste the old physics constraint that we had in the VR pawn. We're going to bring that over to the static mesh, and we're going to copy and paste it in. What we're going to want to do here is actually clear out the component names to be driven, because there's no real reason for us to worry about that for now. We can keep these defaults on if we would like, just for, posterity's purpose. Evidently, this is still going to want to follow a lot of the same principles that we defined inside of the hand, because it's just an object that's going to be following something that we grab with. But there is something that we do want to change. So inside the grab component, you remember we created a reference to a physics constraint reference. We want to just set the physics constraint reference on the construction script of our master grabbable. Of course, we're going to drag in our physics constraint. And this is going to set it up so that all future interactions with this class will automatically have a grabbable assigned to it. And evidently, I did this work in the grabbable small cube, but luckily this isn't a big deal. We can just go ahead and copy and paste that stuff over that way instead of worrying about trying to remedy this another way. And there we have it. We're going to need to be in the small cube anyway. What we're going to want to do is change the parent class to master grabbable. Then we're just going to want to get rid of the extras so we don't have to worry about this. And here we can still scale these down like we did with the other one and not really have to worry about any problems here. We have the physics constraint still in place. Free grab makes sense to me. We do have another object we have to worry about, and that is our pistol. So I'm going to go ahead and open up the pistol, make sure that's in view. Now with the pistol, it's going to be a little bit uglier of a transition, but we're here doing a little bit of refactoring, so it makes sense. So one of the main things you're going to notice is that everything starts getting ugly. There's a pistol, there's a static mesh. One thing that's easy to do is we could just copy and paste the pistol to be this. Now you can see it's a little bit purple. You can just set the material to be default, even if it's a little bit cool. It's already a physics actor. We don't have to worry about anything in regards to that. Let's just make sure there's nothing strange going on here that could cause it to be different. And it doesn't look like that. The grab component, the only real there's a couple of differences here. We'll go over that in a second, but we're just going to want to drag the muzzle location up as well. And then we'll see these two are right here. So with the grab component, there's going to be a rotation. There's also going to be a couple of different things that we're going to want to do here. Oh, if you notice, the grab is scaled up 3 times. We don't really need to worry about that. So now the grab component is not going to be scaled. So we can see, first of all, it's a snap instead of a free grab. That's a pretty simple fix. If you press delete here, you'll say, oh no, there's events that are bound. Go to the event graph. You can see here that, there's going to be this on grabbed, on dropped, or an even better way of doing this. What I like to do is just do find by references by right clicking and go in that little menu. And you can see all the places there's a grab component that's being referenced. So we have the held by hand, stuff like that. So what we want to do is delete all of these functions, as we're not going to worry about it, and replace them with our new reference. This is pretty simple enough. I like to press Control and just drag the little reroute nodes around for execution instead of having to worry about fiddling with all those. Same thing goes for these little spots for firing the gun. You can just keep refreshing this until we finally have replaced every reference inside of our blueprint. And now we just have the component, which we can delete safely, the pistol, which we can delete safely. Now there is going to be something about this grab component we want to do. Beforehand, there was kind of like a strange rotation that I suppose was based off of what Unreal wanted it to work with in regards to the motion controller. For now, you're just going to have to trust me on this. If you make the rotation 90, it's going to take the relative rotation when you grab it and make it always 90 degrees relative to the hand. The other thing that we're going to want to change is the physics constraint here. The 100 limit is going to make so that the gun kind of like moves around in your hand. We don't want any of that. We just want it to be locked because you have a firm grip on the gun with a snap grab. As for everything else, we can leave it default for now, and then when we test in a minute, we'll be able to actually see what problems come up. Alrighty, so now we have our master class. We have the two blueprints that are default, which derive from our grabbable master class. I think it's about time to open up our play in editor and see exactly what we get. So, as you can see, there's a bit of a problem already. You can see that we're not able to grab anything at all. What's happening here is that we never altered the try grab in the VR pawn in order to work properly with our new grab system. So we're going to go ahead and do that next. Alrighty, so once again, we're going to go into the VR pawn here. This part should be a little bit simpler. So you see we have the motion controller that's referenced here. Basically what we want to do now is not use the physics driver, but the hand itself as the physics handle. The reason for this is because we want the object to conform to the hand in our little system of grabs rather than the handle, because then it would just kind of replicate the same behavior that we got with the hand to the motion controller. So we just drag in the hand left for the left hand grab. Then we can drag in the hand right for the right hand grab. Go ahead and compile, and then we can test again and make sure that this is working. Alright, we can tell this is working already a lot better. You can see there's an object, but the collision isn't quite perfect on the gun. Also, when you fire the gun, you can see it's having this kickback, which is nice, but evidently there's a problem with the ammo appearing in a different spot. So something's going off the spawning of the gun. The other problem is that this hand doesn't quite fit exactly how a grab would work. You can see it's kind of like meshing through everything, so we got to fix something with that too. So how are we going to fix up our cube and our guns so that they work a little bit more in line with what we're expecting as a final product? Well, as a start, we can fix our cube since it's going to be a little bit easier. One thing that was weird with the cube was that the distance between the cube and the hand just wasn't very accurate. So you can go ahead and change the limit from 100 to 10. That way the cube will definitely follow the hand a little bit more tightly. Another thing that I would like to do is just enable collision between the two constrained components so that the hand that's grabbing the cube will actually collide. So you'll kind of get a more realistic grabbing simulation. You won't have it merging through the hand like it was in the last little playthrough. Go ahead and save this and close it out. Now we're going to work with the pistol, which is going to have a little bit more that we need to do. Now one of the things that I noticed is that the hand is actually hidden when you put the pistol on. I don't quite like that behavior anymore. Since the hand is physically interacting with the world as well, we're going to want to see the hand. So we could just drag this out, delete the reference, not have to worry about that aspect. Here we still going to want to use the hand so that we can add the mapping context. We're just going to want to make sure we aren't hiding or unhiding the hand anymore here, which we are not. So that fixes that little problem. Another thing that we noticed was that the pistol itself didn't really have a very good collider to it. It didn't feel very good when pushing against things in VR. So we can go ahead and look at the collision of the gun itself. Show collision in the editor. You can see the collision for the gun right now is just a cube, which isn't quite what we want or expect from this type of object. So let's go ahead and open up the static mesh here. We can go over here and show simple collision. Now you can see that cube in all of its glory. What I'm going to do here is just scale up down the cube a bit, or turn off snapping and scaling as well, because we want to have a little bit more smooth movement here. Another thing you could do is just press Control D, or just press Control, or Alt rather, when you're grabbing an object and manipulating it in Unreal Space. We can go ahead and move this around a little bit. Let's make sure there's not any extra, which there isn't. Very nice. Scale this down a bit. So now we're going to have two colliders that conform a little bit more nicely with what this gun is like in the physical simulation. Alrighty, now finally we had the problem with the colliding of the projectile when you fire. One thing that we do is just look at the spawning of the projectile itself, and here we can see we do pass an owner in. We could change this to always spawn, but it's still going to end up colliding and sticking to the gun, and it's still going to cause that physics problem. So there's going to be one thing we want to do with this projectile that's pretty simple. And that's just when we are overlapping with this sphere here, we're going to want to check the other actor and make sure it's not the owner. So we can get owner, we do an equal. We can make sure it's equal or not equal to the other actor by using a not operator. So that if it's not equal to the other actor, then we're going to start doing our collision logic. So now we should have a little bit different behavior, and let's check it out before wrapping up. Okay, so the final test. Here you can see already that the collision for the pistol is working a little bit better. And, we fixed the bug with the firing mechanism, so it's not going to do kickback. It shoots out a projectile properly. Everything seems to be working well with it hitting the gun around and stuff like that, too. And yeah, same thing for the cube. It's a little bit tighter of a grab now. You can even tap your hand with it and play around with it a bit. See if you can grasp onto it and kind of just have it rest on the other hand here, but it's not going to work too well. So, but mission accomplished, I would say. So, happy to have this done. All right, well, that is about it for this tutorial. There's a lot of ways you can set up physical interaction in Unreal and grabbing and, how you can work with your hands and objects colliding while they're grabbed. There's also a lot of ways you could set it up. Like what I did is not the end-all be-all when it comes to, every system that you could possibly imagine in VR, but it is one simple way you can get it going, and, it could form a base foundation for you to build something bigger upon. Really hope you like this tutorial. If you would like to see more content like this, just make sure to like and subscribe to the channel. We'd love to create more and show you everything there is to know about Unreal Engine from, our experience inside of the game design industry. So, thank you.